Hey everyone, welcome back to the Mindverse. Today, we're starting our journey across the solar family, and our very first stop is Mercury, the smallest, fastest, and one of the most extreme planets in the solar system. At first glance, Mercury doesn't look like much. Through a telescope, it appears as a dull, cratered world, gray and scarred, almost like our moon. But the closer we look, the more fascinating it becomes. Mercury is a planet of extremes, burning hot during the day, freezing cold at night, with a bizarre sense of time, and even a few secrets hiding in its shadows. This is Mercury, and its story is one of survival and paradox. Mercury is tiny compared to the other planets. Its diameter is only about 4,880 kilometers, less than half the size of Earth, and just a little bigger than our moon. If Earth were a basketball, Mercury would be a golf ball. You could line up 3 Mercuries side by side and still not reach Earth's width. And yet Mercury is incredibly dense. More than half of its volume is a giant iron core. It's as if the planet is an oversized ball of metal with just a thin rocky shell on top. Many scientists think that long ago Mercury was larger, but a massive collision stripped away much of its outer layers, leaving behind this iron-rich remnant. Mercury orbits the Sun at an average distance of just 58 million kilometers, about 1/3 of Earth's distance. Being so close, it receives sunlight 7 times more intense than Earth does. From Mercury's surface, the Sun would look more than 3 times larger than in our sky. The result is extreme surface temperatures. During the day, the ground can heat to about 430 degrees Celsius, hot enough to melt lead. But when night falls, the heat disappears instantly, and temperatures drop to minus 180 degrees Celsius. With no thick atmosphere to trap heat, Mercury swings between the hottest and coldest extremes of any planet. Imagine standing there, your shadow boiling on one side and freezing on the other. Time on Mercury is just as strange. A year one orbit around the Sun lasts only 88 Earth days, the shortest year in the solar system. But a day one full rotation lasts 59 Earth days because of the way Mercury spins and moves. The time from one sunrise to the next is actually 176 Earth days. If you live there, you'd celebrate 4 birthdays in a year, but you'd only see 2 sunrises. That means entire seasons could pass between the rising and setting of the Sun. Mercury's clock doesn't work like ours. It runs on its own bizarre rhythm. Mercury's surface is ancient and battered. It has no atmosphere to burn up incoming meteors, so every impact leaves its mark. Craters cover the landscape, reminders of billions of years of collisions. One of the most dramatic is the Calaris Basin, a giant crater about 1,550 kilometers wide. The impact that formed it was so powerful that shockwaves rippled through the entire planet, creating strange ridges and cliffs on the opposite side. Mercury is also covered in enormous scarps or cliffs, some stretching hundreds of kilometers. These were formed as Mercury cooled and shrank. Imagine a planet literally wrinkling as it aged, like dried fruit losing moisture. That's what happened to Mercury. For a long time, scientists thought Mercury was completely geologically dead, a quiet rock. But spacecraft have shown us otherwise. Some features on the surface look surprisingly young, suggesting Mercury may still have a little geological activity. Its core is still partly molten, which is why Mercury has a magnetic field, though weaker than Earth's. This field was a surprise for such a small planet. Most worlds this small lose their magnetic fields long ago, but Mercury is still clinging to one. Its core, dense and molten, may be the reason. Now here's something truly unexpected. You'd think Mercury, being so close to the Sun, would be completely dry. Yet in 2012, NASA's Messenger spacecraft discovered water ice at Mercury's poles. In deep craters that never see sunlight, temperatures are so cold that ice can survive for billions of years. Alongside the ice, scientists even found organic molecules, the kind that are the building blocks of life. Imagine that. A planet scorched by the Sun, yet hiding frozen water in its darkest corners. It's one of Mercury's greatest surprises. Exploring Mercury has always been difficult. Only 2 spacecraft have ever visited. Mariner 10 flew past in the 1970s, giving us our first close-up images. Decades later came Messenger, which orbited Mercury from 2011 to 2015, mapping its surface and revealing its mysteries. Messenger showed us volcanic plains, evidence that Mercury once had active volcanoes spewing lava across the land. It discovered the cliffs that proved the planet shrank, and it revealed those icy patches at the poles. Today, a new mission called BP Colombo, led by Europe and Japan, is on its way, scheduled to arrive in 2025. With it, we'll learn even more about this tiny, strange world. If you could stand on Mercury, it would be unlike any view on Earth. The sky would always be black, even during the day, because there's no atmosphere to scatter sunlight into blue. The Sun would blaze enormous and brilliant, casting sharp shadows. The horizon would curve quickly because the planet is so small. At night, Earth would appear as a tiny blue star, with Venus shining nearby as a bright white light. Around you, the land would be silent, covered in craters, cliffs, and rocky plains, frozen in time. It would feel like standing in a cosmic museum. a world that has hardly changed in billions of years. Mercury's lack of atmosphere also means no weather, no clouds, no rain, no erosion. Craters that formed billions of years ago still remain sharp and clear. Every scar tells a story. You could walk for miles and see the evidence of ancient impacts, volcanic flows, and the wrinkles of a shrinking world. Yet, even in this silence, Mercury is not lifeless in its importance. It has shaped our understanding of planetary science. It shows us what happens when a world loses its atmosphere. It shows us how planets cool and contract. It shows us the balance between heat and cold, and how a planet can be both scorched and frozen. Mercury is often overlooked because it's small and hard to see in the sky. It rises and sets close to the sun, visible only for a short time after sunset or before sunrise. But this small dot of light holds enormous significance. It is a survivor from the solar system's violent beginning, a planet that has endured collisions, shrinkage, and the constant fury of the sun. It is a reminder that even the smallest world can hold mysteries that reshape our understanding of the cosmos. So, the next time you spot Mercury, remember that behind that tiny, shining point is a planet of extremes. The smallest planet with one of the biggest cores, a place without air, but with frozen water. A world where days outlast years, and the sun rules the sky with overwhelming power. Mercury may not host life or lush landscapes, but it holds stories about how planets form, evolve, and endure. It is the first chapter in the solar family's tale, and though it is closest to the sun, it has remained in the shadows of our attention. Now, as we learn more, Mercury steps into the light, showing us that even the smallest planet has a grand story to tell. Venus, and though Mercury has shown us the smallest planet's grand story, our journey does not stop there. Moving just a little farther away from the sun, we reach a planet that looks like Earth's twin in size and shape, yet in truth, it is a world of fire and suffocating skies. This is Venus, a planet that hides beneath thick clouds, a place that could have been Earth-like once, but instead became one of the harshest environments in the solar system. At first glance, Venus and Earth are almost the same. Venus is only slightly smaller. The first and most striking feature of Venus is its atmosphere. Instead of a breathable sky, Venus is wrapped in a suffocating blanket of carbon dioxide, with clouds made of sulfuric acid droplets. The air pressure at the surface is about 92 times that of Earth's, the equivalent of being almost a kilometer underwater in Earth's oceans. Imagine stepping onto the planet. Before you could even take a breath, the crushing pressure would collapse your lungs. Even if you were inside a suit, the heat would overwhelm you within minutes, and the heat is extraordinary. Venus is the hottest planet in the solar system, even hotter than Mercury. Despite being farther from the sun, the thick carbon dioxide atmosphere traps heat so efficiently that the surface temperature averages 465 degrees Celsius. That's hot enough to melt lead, zinc, and many other metals. Day or night, poles or equator, it doesn't matter. Venus's thick atmosphere spreads the heat evenly, making the entire planet a furnace without relief. Unlike Mercury, which has extremes of hot and cold, Venus is consistent in its torment. Now picture the sky. On Venus, you would never see the sun or the stars. The clouds are permanent, thick, and poisonous. They reflect sunlight so strongly that from Earth, Venus shines as the brightest planet in our night sky. But underneath those clouds, the surface is trapped in a dim orange twilight, with sunlight filtered through layers of acid haze. The winds high in the atmosphere scream at hundreds of kilometers per hour. But near the ground, the air is so dense that the winds crawl at just a few kilometers per hour. Yet, because of the pressure, even a gentle breeze would feel like pushing against a strong current of water. Venus also has one of the strangest rotations of any planet. It spins backward compared to most of the others. If you could look down from above the solar system, you'd see Venus turning in the opposite direction of Earth. That means on Venus, the sun rises in the west and sets in the east. But even more bizarre, Venus rotates incredibly slowly. One day on Venus, the time it takes to spin once on its axis, is about 243 Earth days. Yet a year on Venus, its orbit around the sun, lasts only 225 Earth days. That means a single day on Venus is actually longer than its year. Even stranger, because of the way Venus rotates and orbits, a person standing on the surface would see the sun rise, set and rise again only once every 117 Earth days. Time on Venus moves at a pace that defies our earthly intuition. The surface of Venus is as hostile as its sky. Thanks to radar mapping, we know it is covered in vast volcanic plains, mountains, and immense plateaus. About 80% of the surface is lava flows, evidence of a planet reshaped by volcanic activity. Some volcanoes are larger than anything on Earth. Maxwell Montes, the tallest mountain on Venus, rises 11 kilometers high, even taller than Mount Everest. There are also huge shield volcanoes, lava domes, and vast rift valleys. Scientists believe Venus may have been volcanically active in recent times, and some data even suggest eruptions might still happen today. Imagine the ground trembling as lava bursts forth into an already hellish atmosphere, the heat intensifying in a world already beyond scorching. Another striking feature of Venus is its lack of plate tectonics. On Earth, our surface is divided into moving plates that drift, collide, and recycle the crust. This helps regulate our climate and release heat from the planet's interior, but Venus seems to have a solid, immobile crust. Instead of moving plates, Venus appears to undergo catastrophic resurfacing events. It's as if, every few 100 million years, the planet's heat builds up until the crust softens, melts and floods the entire surface with lava, erasing most of its geological history. The surface we see today may be relatively young, less than 1 billion years old, a fresh scar in planetary time. Despite its hostile surface, Venus has been visited by more spacecraft than Mercury. The Soviet Union's Venera missions in the 1960s and 70s were the first to land on another planet, sending back haunting images from the surface before being destroyed by the heat and pressure. These photos showed flat, rocky plains under a hazy sky, giving humanity its first glimpse of an alien world's surface. Some of these landers survived only minutes. The most successful lasted about 2 hours before succumbing. Later, NASA's Magellan spacecraft mapped the entire planet using radar in the 1990s, revealing its complex terrain. Today, new missions are being planned by NASA and ESA to revisit Venus and study its atmosphere and geology in detail. Scientists are particularly interested in whether Venus still has active volcanoes and what its past climate might have been like. You see, one of the greatest mysteries of Venus is whether it was always this way. Some models suggest that billions of years ago Venus might have had oceans, a thinner atmosphere, and even conditions suitable for life. But something went terribly wrong. Perhaps too much volcanic activity released massive amounts of carbon dioxide. Perhaps its proximity to the sun made it harder to hold on to water. Gradually, Venus entered a runaway greenhouse effect, where heat from the sun was trapped more and more until the oceans boiled away, leaving the scorched, suffocating world we see today. Venus is a warning of what happens when greenhouse gases spiral out of control. It's a vision of climate change on a planetary scale. Yet despite its dangers, Venus fascinates scientists because of its similarities to Earth. Why did two nearly identical planets evolve so differently? Why is one blue and full of life while the other is yellow, toxic and lifeless? These questions drive new missions and research. By studying Venus, we not only learn about its history but also gain insights into our own planet's future. Could Earth ever become like Venus if our climate spirals out of balance? Or could Venus hold secrets that explain how planets in general change over billions of years? Some scientists even speculate about the possibility of life in Venus's atmosphere. While the surface is far too hot and hostile, about 50 kilometers above the ground, the atmosphere is cooler, with pressures similar to Earth's. In 2020, researchers detected a possible sign of phosphine gas, which on Earth is often produced by microbes, though the detection is debated. It raised the exciting possibility that some form of life could exist in the clouds of Venus. Imagine microscopic organisms drifting in a yellow-orange sky, living in acid droplets, surviving where everything else would perish. It's still unproven, but it reminds us to never dismiss even the harshest worlds. If you could somehow stand on Venus, the experience would be overwhelming. The air would crush you instantly, the heat would burn through any protection in minutes, and the clouds above would glow dimly, giving the world an eerie, twilight atmosphere. The ground would stretch out in rocky plains, with distant volcanoes looming like giants in the haze. The silence would be absolute, but the weight of the air would press down on every surface. You would see no stars, no sun, only a thick orange glow. It is as alien as a world can be, yet also hauntingly familiar in its Earth-like proportions. Venus is a paradox. It is our twin, yet our opposite. A planet that could have been a second Earth, but instead became an inferno. It shows us how delicate the balance of a planet's atmosphere can be, how quickly a world can change, and how catastrophic those changes can become. For humanity, Venus is not just a scientific puzzle, but a mirror held up to remind us of what we must protect on Earth. And so, as we continue our journey through the solar family, Venus leaves us with lessons in extremes, a world of crushing pressure, endless heat, volcanic plains, and poisonous skies. A planet that shines brilliantly in our night sky, but hides a story of destruction beneath its beauty. Venus is Earth's sister, yes, but a sister that chose a very different path. Venus, with its suffocating atmosphere and relentless heat, showed us how a planet so similar to Earth could follow a very different path. And so, as we move outward in the solar family, we arrive at the third planet from the Sun, Earth, our home. The only world we know that carries life in astonishing variety. When seen from space, Earth is breathtaking, a glowing sphere of blue oceans, green lands, swirling clouds and icy poles. Unlike Mercury's barren surface or Venus's inferno, Earth is balanced, stable, and alive. Earth is the largest of the rocky planets, with a diameter of about 12,742 kilometers. Its size and mass give it the perfect strength of gravity to hold onto an atmosphere, thick enough to protect life, but not so heavy that it crushes the surface. Its position is also just right. About 150 million kilometers from the Sun, in what we call the habitable zone. At this distance, temperatures allow water to remain liquid, and water is the foundation of everything alive. More than 70% of Earth's surface is covered by oceans, making it unique among its neighbors. The blue seas regulate climate, transport heat, and support life in endless forms. The presence of water alone makes Earth special, but it is the combination of many factors that makes it truly extraordinary. Earth's atmosphere is rich in nitrogen and oxygen, with small amounts of carbon dioxide and water vapor. Oxygen fuels breathing life, while the ozone layer high above absorbs dangerous ultraviolet rays from the sun. Without this protective layer, complex organisms could never survive. At the same time, greenhouse gases trap enough heat to keep the planet warm, but not so much that it spirals into Venus-like extremes. Another crucial shield comes from deep within the planet. Earth has a molten iron core that generates a magnetic field stretching far into space. This field deflects much of the solar wind, streams of charged particles from the sun that could strip away the atmosphere over time. On Mars, which lacks such a strong field, much of the air has been lost. On Earth, this invisible shield has preserved our sky and oceans for billions of years, creating stability for life to evolve. Earth's surface is restless and alive with geology. Unlike Venus, which is locked under a rigid crust, Earth's outer shell is broken into tectonic plates that slowly drift across the globe. These plates collide and pull apart, forming mountains, valleys, and oceans. They also recycle material back into the planet's interior, releasing gases and balancing carbon dioxide levels over long cycles. This system helps stabilize the climate and prevents extremes. Volcanoes, earthquakes, and shifting continents are all part of Earth's dynamic nature, and without them our planet would be very different. But what truly sets Earth apart is life. Nowhere else, at least so far, have we found living organisms. Life here began billions of years ago with tiny microbes, and from that simple beginning, it branched into the incredible diversity we see today. Plants, animals, fungi, and countless microorganisms form ecosystems that cover every environment. Life has adapted to survive in scalding vents on the ocean floor, in frozen tundras, in deserts, and in rainforests. Earth's biosphere is a web of connections, each part relying on others in delicate balance. For humans, Earth is not just a planet, it is our cradle. Our species has lived here for only a short time compared to Earth's long history, but in that time we've spread across continents, built civilizations, and reached into space itself. Every story, every culture, every memory has unfolded here. The soil provides our food, the air sustains our breath, the water nourishes us. We are entirely bound to this world, even as we dream of exploring others. Yet Earth also reminds us of fragility. Its climate has shifted through ice ages and warm periods in the past, often changing the course of life. Today, human activity is driving new changes. By burning fossil fuels and releasing greenhouse gases, we are altering the delicate balance of the atmosphere. Temperatures are rising, seas are climbing, weather is shifting. Looking at Venus, we saw the danger of a runaway greenhouse effect. On Earth, that vision serves as a warning of what could happen if balance is lost. From space, Earth appears whole and united. Astronauts describe the overview effect, the awe of seeing Earth as a single sphere with no borders, no divisions, only oceans, continents, and clouds. It is humbling, a reminder that all of humanity shares one home. The thin blue line of the atmosphere is visible from orbit, fragile and narrow, protecting life below. Against the darkness of space, Earth looks small yet precious, like a jewel hanging in the void. The Moon, Earth's constant companion, also plays a role in shaping our world. It stabilizes the planet's tilt, keeping the climate steady over long timescales. Its gravity drives the tides, which influence ecosystems and human activity alike. The Moon itself is thought to have formed from a colossal impact in Earth's early history. When a Mars-sized body struck the young planet, the debris from that impact coalesced into our Moon, forever linking its story with our own. Comparing Earth with its neighbors makes its uniqueness clear. Mercury is too small to hold an atmosphere. Venus is smothered by one that destroys habitability. Mars is cold and dry, with only faint traces of water. Earth is the only world with the right balance of temperature, atmosphere, water, and protection. It sits comfortably in the Goldilocks zone, not too hot, not too cold, but just right. Beyond our solar system, astronomers have found thousands of exoplanets, some rocky, some inhabitable zones, some even with atmospheres. Perhaps some are Earth-like, perhaps some even host life. But until we know for sure, Earth remains the only confirmed living world. It is our baseline, the measure against which we compare all others. Imagine looking at Earth with alien eyes. You would see oceans glittering in sunlight, continents green and golden, polar caps shining white. You would see storms spiraling across the seas, rivers carving land, and perhaps at night the faint sparkle of cities glowing on the surface. You would recognize this as no ordinary rock but a vibrant, active, living planet. Earth's history is filled with resilience. It has endured asteroid impacts that wiped out species, volcanic winters that darkened skies, ice ages that froze landscapes, Life has nearly vanished more than once, yet always returned. Still, this resilience has limits. Earth is strong, but it is not invincible. The balance that allows life exists only within certain boundaries. Cross them, and the planet can shift into states hostile to complex life. Understanding this makes Earth not just a wonder, but also a responsibility. As we continue our journey outward into the solar family, Earth stands as a reminder of what is possible when conditions align. It is proof that among lifeless rocks and hostile giants, a planet can harbor oceans, forests, and beings capable of asking questions about the stars. Earth is unique not only in its nature but in its role. It is the foundation for our exploration, the perspective from which we seek to understand all others. And no matter how far humanity may travel, Earth will always be more than just another planet in orbit around the sun. It is home, the birthplace of life, the keeper of stories, and the heart of the solar family. Earth, with its balance of oceans, air, and life, showed us the rare perfection that makes a living world possible. And now, as we step outward to the fourth planet from the sun, we arrive at a place that has long captured human imagination more than any other. This is Mars, the red planet, a world that is cold and barren today, yet one that may have once flowed with rivers, lakes, and seas. Among all the planets beyond Earth, Mars is the one that feels most familiar, and perhaps the one that holds the greatest promise for humanity's future. When you look up at the night sky, Mars is easy to spot. It shines with a reddish glow, brighter than most stars, a steady point of light that has inspired myths for millennia. To ancient civilizations, its color resembled blood, so they often associated it with war. But beneath its fiery appearance, Mars is a world far more subtle, shaped by ancient waters, towering volcanoes, and vast canyons. Mars is smaller than Earth, with a diameter of about 6,779 kilometers, just over half the size of our home. Its gravity is weaker, only about 38% of Earth's. If you weigh 70 kilograms on Earth, you'd weigh less than 27 kilograms on Mars. The weaker gravity also means Mars could not hold onto a thick atmosphere. Today, its air is incredibly thin, less than 1% of Earth's pressure at sea level. You could not breathe it, even if you tried, because it is mostly carbon dioxide with only traces of oxygen. Without protection, a human standing on the surface would suffocate within seconds. The thin atmosphere also means Mars is a cold planet. Average temperatures hover around minus 60 degrees Celsius, though at the equator on a sunny day it can rise to a mild 20 degrees. At night, however, it plunges back down to minus 70 or colder. The air does little to trap heat, and the planet is exposed to the full force of solar radiation and cosmic rays. For any future explorers, protection would be essential. Yet despite its thin atmosphere, Mars has weather. Dust storms sweep across the planet, sometimes covering the entire globe for weeks. The sky is tinted pink or butterscotch by fine dust particles, and winds carve the landscape over time. Unlike Earth's blue sky, Mars' sky is tinted by iron-rich dust, the same dust that coats its surface and gives the planet its iconic red color. But Mars is not just dust and cold air. Its surface tells a story of grandeur and mystery. Consider Olympus Mons, the tallest volcano in the solar system. It rises 22 kilometers high, nearly 3 times the height of Mount Everest, and spreads so wide it could cover the entire state of Arizona. Then there is Valles Marineris, a canyon system stretching more than 4,000 kilometers long, as wide as the United States, and up to 7 kilometers deep. If you stood on its edge, the cliffs would vanish into haze before reaching the bottom. No landscape on Earth compares to such extremes. Perhaps most fascinating is the evidence of water. Today, Mars is dry on the surface, its rivers long gone. But spacecraft and rovers have found countless signs that liquid water once flowed freely. Ancient riverbeds, deltas, and lake basins are etched into the terrain. Minerals that only form in water have been discovered in rocks. Even now, polar ice caps hold frozen water and carbon dioxide, and beneath the surface, there may be reserves of liquid water locked away in salty brines. Billions of years ago, Mars may have had oceans covering vast regions of its northern hemisphere. If so, it raises one of the biggest questions in science. Could life have once existed there? That question drives much of our exploration of Mars. Dozens of spacecraft have orbited, landed, and roved across its surface. From Viking in the 1970s to Spirit, Opportunity, Curiosity, and Perseverance. Each mission has uncovered more about Mars's past. We have learned that the planet once had a thicker atmosphere, a magnetic field, and flowing water, conditions more hospitable than today. The Perseverance rover, launched in 2020, is even collecting samples that may one day be returned to Earth, searching for signs of ancient microbial life in rocks billions of years old. For humanity, Mars is not just a subject of study but a dream of the future. It is the most realistic candidate for human exploration beyond the moon. Its days, cold sols, are about 24.6 hours long, close to Earth's cycle. It has seasons, polar caps, and landscapes that feel strangely familiar, almost like deserts or highlands on Earth. Scientists imagine future colonies powered by solar energy, protected under domes or buried in lava tubes, growing food and building a new frontier. Challenges are immense: radiation, cold, thin air, and dust storms. But the dream remains strong because Mars offers something no other planet does: the possibility of being a second home. Mars also has two tiny moons, Phobos and Deimos. They are irregular potato-shaped rocks, likely captured asteroids. Phobos orbits so close to Mars that it rises and sets twice a day, moving faster than the planet rotates. In millions of years, tidal forces may tear it apart, scattering its fragments into a ring around Mars. These moons are small and strange, but they add to the character of the red planet system. Culturally, Mars has always fascinated us. From ancient myths to modern science fiction, it has been imagined as a place of gods, monsters, canals, and civilizations. Writers dreamed of Martians building canals to save their dying world, or alien invaders coming from Mars to Earth. Though those fantasies turned out to be false, they reflect our deep connection to Mars as a mirror of our hopes and fears. In reality, Mars is not home to civilizations but to stories carved in rock. Stories of a time when water flowed and climates shifted. If you could stand on Mars, what would you see? The sky above would be tinted dusty pink, the sun smaller and fainter than on Earth. The horizon would stretch across plains of rust-colored soil, dotted with boulders and rocky hills. Mountains would rise in the distance, far larger than any on Earth. Dust devils might swirl across the surface, lifting fine particles into the air. At night, the cold would be sharp, and the sky filled with stars, unblurred by thick atmosphere. Phobos and Deimos would drift overhead, small but fast-moving, reminders that this is a different world. Mars is a planet of paradox. It is small yet immense in its landscapes. It is barren yet once alive with water. It is cold yet full of warmth in the dreams it inspires. It is inhospitable today but may one day host human footprints and settlements. In studying Mars, we learn not only about the planet itself but about Earth too. We see how planets evolve, how atmospheres are lost, how climates shift. Mars is a lesson in change, a story of what happens when a once habitable world loses its protection and becomes vulnerable to the sun's relentless forces. And still, Mars offers hope. It tells us that planets can hold water, that conditions for life may not be as rare as we once thought. It invites us to search, to imagine, and to prepare for a future where humans may walk on another planet. Mars is both a relic of the past and a vision of the future. As we leave the red planet behind in our journey through the solar family, we carry its mysteries with us. Did life ever begin here? Could life still linger, hidden underground in salty water? And will humans someday call Mars a second home? The answers are still waiting, etched into its rocks and buried beneath its soil. Mars remains silent for now, but one day, we may hear its story more clearly, not just through robots, but through our own footsteps in its dust. Mars, with its deserts, canyons, and whispers of ancient rivers, leaves us with a haunting question about life and the future of exploration. But as we step farther outward into the solar family, we now enter a new kind of world. One unlike the rocky planets we've seen so far. The next planet is so massive, so dominant, that it is often called the king of the solar system. This is Jupiter, the fifth planet from the Sun. A gas giant so huge that all the other planets combined would still not equal its size. Jupiter is immense. With a diameter of about 142,000 kilometers, it is more than 11 times wider than Earth. Over 1,300 Earths could fit inside it. Yet it is made mostly not of rock or solid ground, but of swirling gas and liquid. Its mass is so great that it accounts for more than 2/3 of the planetary mass in the entire solar system. In many ways, Jupiter is like a failed star. If it had been about 80 times more massive, nuclear fusion would have ignited in its core, and it would have shone like a sun. Instead, it became a planet, but one of staggering proportions. When you look at Jupiter through a telescope, its surface isn't solid land, but a swirling canvas of clouds. Bands of white, brown, and orange wrap around the planet, created by powerful jet streams blowing in opposite directions. Storms rage endlessly in these belts, the most famous being the Great Red Spot. This gigantic storm has been spinning for at least 350 years, possibly much longer, and it is so large that 3 Earths could fit inside it. Imagine a hurricane bigger than our planet itself, lasting for centuries. That's the scale of Jupiter's weather. The atmosphere of Jupiter is mostly hydrogen and helium, with traces of methane, ammonia, and water vapor. As you descend into its layers, the pressure increases to unimaginable levels. The gas is compressed into liquid hydrogen, and deeper still, scientists believe there may be a layer of metallic hydrogen, where hydrogen atoms are squeezed so tightly that they behave like a metal, conducting electricity and generating Jupiter's powerful magnetic field. If you kept falling, you might eventually reach a core of rock and ice, though it is hidden under thousands of kilometers of fluid layers. That magnetic field is one of Jupiter's most astonishing features. It is the strongest of any planet, about 20,000 times stronger than Earth's. It creates huge radiation belts, dangerous enough to fry spacecraft that get too close without protection. It also produces massive auroras at the poles, dazzling lights even more powerful than Earth's northern and southern lights. Jupiter's magnetosphere is so large it stretches millions of kilometers into space, making it one of the largest structures in the solar system. Jupiter is not alone in its vastness. Orbiting around it are at least 95 moons, a miniature solar system in itself. 4 of them, called the Galilean moons, Io, Europa, Ganymede, and Callisto, were first observed by Galileo Galilei in 1610. Each of these worlds is unique and could be considered a planet in its own right. Io is the most volcanically active body in the solar system, with hundreds of eruptions constantly reshaping its surface. Lava fountains and sulfur plumes shoot kilometers high, painting the moon in fiery colors. Europa, in contrast, is smooth and icy, with a surface crisscrossed by cracks. Beneath its frozen shell lies a vast ocean of liquid water, more than twice the volume of Earth's oceans combined. Scientists believe Europa's ocean may be one of the best places to search for alien life. Ganymede is the largest moon in the solar system, even bigger than Mercury, and it has its own magnetic field. Callisto, heavily cratered and ancient, preserves the scars of billions of years of impacts. Together, Jupiter and its moons form a world of endless fascination. It's not just a planet, it's a system within a system, a place where volcanic fire, icy oceans, and massive storms coexist. Jupiter's gravity also plays a vital role in shaping the entire solar system. Its immense pull acts like a guardian, deflecting comets and asteroids that might otherwise strike the inner planets. Some scientists believe that without Jupiter, Earth might have been bombarded so often that life could never have developed. In this way, Jupiter may have helped shield our fragile home, making it possible for us to exist. But Jupiter can also be a disruptor. Its gravity stirs up the asteroid belt, preventing the rocks there from forming into a planet. Instead, it keeps the region unstable, scattering asteroids across the solar system. Sometimes those asteroids are sent inward, creating both danger and opportunity for Earth. Jupiter, in this sense, is both protector and threat, a double-edged influence on the story of life. If you could stand near Jupiter, the sight would be unlike anything on Earth. But you could never truly stand on it. There is no solid surface. The deeper you go, the atmosphere thickens, crushing with pressures far beyond human endurance. Temperatures climb thousands of degrees. There is no place to land, only endless skies of storms and lightning. Yet from a distance, the view would be breathtaking. The great red spot spinning like a cosmic whirlpool, the colored bands rippling across the globe, and the giant moons hanging in the sky like worlds of their own. Jupiter also radiates more heat than it receives from the sun, glowing faintly in the infrared. This heat comes from the slow contraction of the planet under its own gravity, a leftover from its formation. Even now, billions of years later, Jupiter is still releasing the energy of its birth, a reminder of the fiery beginnings of the solar system. Culturally, Jupiter has long been associated with kingship, gods, and power. The Romans named it after their chief deity, Jupiter, the king of the gods. Its presence in the sky, bright and commanding, reflects that legacy. In modern times, it continues to command attention, both scientifically and symbolically, as a planet of unmatched size and influence. Our spacecraft have revealed much about Jupiter. Pioneer and Voyager first flew past it, sending back images of swirling clouds and giant moons. Later, the Galileo orbiters spent years studying the planet and its satellites. More recently, the Juno spacecraft has been orbiting Jupiter since 2016, diving close to its cloud tops and measuring its magnetic field, gravity, and atmosphere. Juno's data has revealed stunning new details, including images of Jupiter's poles with gigantic cyclones arranged like petals of a flower, storms thousands of kilometers wide that swirl endlessly. Jupiter reminds us of the diversity of worlds in our solar system. It is not a place for life as we know it, at least not on its gaseous surface. But its moons, especially Europa, may harbor the conditions for life in hidden oceans. The search for alien microbes beneath Europa's ice may one day become one of the greatest discoveries in human history, and that search begins with understanding Jupiter. As we leave Jupiter in our journey, we carry with us a sense of awe at its scale and power. It is the giant among planets, a world that could have been a star, a guardian and a threat, a canvas of storms and mysteries. Jupiter shows us that not all planets are Earth-like. Some are so immense and alien that they challenge our imagination. Yet even in its alien nature, Jupiter is a vital part of the solar family, shaping the lives of worlds around it, perhaps even shaping our own existence. The journey outward continues, and beyond Jupiter lies another giant, a planet with rings so beautiful they have captured human wonder for centuries. If Jupiter is the king, then Saturn is the jewel of the solar system, waiting for us just ahead. Jupiter, the mighty king of planets, showed us a world of unmatched size and power, surrounded by moons that could each tell a story of their own. But now, as we continue outward through the solar family, we meet a planet that rivals Jupiter in majesty, not with sheer bulk, but with beauty. Saturn, the sixth planet from the Sun, is instantly recognizable for its magnificent rings, a sight so breathtaking that it has become an icon of astronomy. If Jupiter is the king, Saturn is the jewel of the solar system. Saturn is a giant like Jupiter, though slightly smaller. Its diameter is about 120,500 kilometers, still more than 9 times wider than Earth. Its mass is enormous, over 95 times that of Earth, but compared to its size, Saturn is surprisingly light. Its density is so low that if there were a cosmic ocean large enough, Saturn would float in it. Among all planets, Saturn is the least dense, a giant of gas that is more delicate than it looks. From a telescope, Saturn's golden hue and shining rings are mesmerizing. But the planet itself is a swirling ball of hydrogen and helium, with no solid surface to stand on. Like Jupiter, Saturn has bands of clouds driven by powerful winds, some blowing over 1,800 kilometers per hour. Storms erupt across its atmosphere, including massive tempests, larger than Earth. In 2010, a storm broke out in Saturn's northern hemisphere that grew so huge it wrapped around the entire planet, a bright scar in its cloud tops that lasted months before fading. Yet what sets Saturn apart are its rings. Stretching hundreds of thousands of kilometers into space, they are made of countless particles of ice and rock, ranging from tiny grains to chunks the size of houses. From a distance, the rings look solid and smooth, but up close they are a delicate, dynamic system, shaped by gravity and motion. The main rings are only about 10 to 30 meters thick, astonishingly thin compared to their vast width. Sunlight glints off the icy particles, making the rings glow with ethereal beauty. The origin of the rings remains a mystery. Some scientists think they formed from a shattered moon, torn apart by Saturn's gravity. Others believe they are remnants from the early solar system, leftover material that never coalesced into a moon. Whatever their source, the rings are not permanent. Over millions of years, they may gradually fall into the planet, leaving Saturn bare. For now, though, they remain one of the most spectacular sights in the cosmos. Saturn, like Jupiter, is surrounded by a family of moons, more than 140 known so far, with new ones still being discovered. Among them are some of the most fascinating worlds in the solar system. Titan, Saturn's largest moon, is bigger than Mercury and cloaked in a thick orange atmosphere of nitrogen and methane. On Titan, rivers and lakes exist, but they are not made of water. Instead, they are filled with liquid methane and ethane, hydrocarbons that could serve as the building blocks for exotic forms of life. Titan's atmosphere is so dense that humans could strap on wings and fly through it, though they would need protection from the bitter cold. Around -180 degrees Celsius, another moon, Enceladus, has captured enormous attention. Only about 500 kilometers across, it would seem unremarkable, yet it hides an ocean beneath its icy crust. Geysers of water and ice shoot out from cracks near its south pole, spraying material hundreds of kilometers into space. These plumes contain organic molecules, heat, and salt, all signs that Enceladus's hidden ocean could harbor life. The Cassini spacecraft even flew through these plumes, sampling their chemistry and confirming that beneath the ice, a salty warm sea exists. Enceladus is now considered one of the top candidates for discovering extraterrestrial life. Other moons add to the variety. Mimas, with its enormous crater, looks like the Death Star from Star Wars. Iapetus has one hemisphere far darker than the other, creating a dramatic two-tone world. Rhea, Dione, and Tethys, though smaller, are icy and cratered, preserving the history of impacts over billions of years. Together, Saturn's moons create a miniature solar system full of surprises, each offering its own mysteries. Saturn also has a powerful magnetic field, though weaker than Jupiter's. It creates dazzling auroras near the poles, glowing in ultraviolet light as charged particles interact with the atmosphere. Cassini revealed that these auroras are complex and ever-changing, linked to the solar wind and Saturn's own rotation. The Cassini mission, launched in 1997, transformed our understanding of Saturn. For more than 13 years, the spacecraft orbited the planet, diving through the rings, flying past moons, and capturing countless images. Cassini delivered the Huygens probe to Titan, which parachuted down and sent back the first pictures from the surface of that alien world. Later, as its mission came to an end, Cassini performed daring dives between Saturn and its innermost ring, skimming just thousands of kilometers above the cloud tops. Finally, in 2017, Cassini plunged into Saturn itself, ending its journey in a blaze of discovery, ensuring that it would not contaminate potentially life-bearing moons like Enceladus. If you could approach Saturn, the sight would be unforgettable. The planet's golden globe rising in the distance, circled by wide shining rings that stretch across the sky. The view from Titan's surface would be even more surreal, a hazy orange sky with Saturn looming overhead, enormous and majestic. Standing there, you would feel as if you were gazing at a scene from a dream. Saturn plays an important role in the architecture of the solar system. Its gravity, like Jupiter's, helps shape the orbits of countless objects, influencing the asteroid belt and the outer reaches beyond. In the early days of the solar system, Saturn's dance with Jupiter may have helped scatter comets and small bodies, contributing to the distribution of water and organic materials across the planets. Without Saturn, the solar system might not have developed in the way it did. In myth and culture, Saturn has long been a symbol of time, agriculture, and cycles. The Romans named it after their god of wealth and plenty, reflecting its prominent presence in the sky. To modernize, it is a symbol of beauty and wonder, the planet that reveals how diverse and unexpected worlds can be. Yet Saturn also teaches us about impermanence. Its rings, as glorious as they are, may not last forever. Scientists estimate they could disappear in as little as 100 million years, a blink of an eye compared to the age of the solar system. We live in a time when Saturn wears its crown, but one day, the jewel may fade. Saturn reminds us that beauty and mystery can coexist. It is not just a planet of gas and storms, but a system of moons with hidden oceans, atmospheres, and secrets. It challenges us to explore, to imagine what lies beneath Titan's haze or Enceladus's ice. It shows us that life's possibilities extend beyond Earth-like conditions, that even in freezing methane lakes or salty subsurface seas, the ingredients for biology might arise. As we leave Saturn behind, we carry an image that will never fade, a golden giant wrapped in delicate rings, accompanied by a family of worlds that could change our understanding of life itself. Beyond Saturn lies the realm of the ice giants, Uranus and Neptune, planets stranger still, tilted and distant, waiting with their own peculiar stories. But Saturn will remain forever in our imagination, the planet that reminds us that even in the vastness of space, beauty can take forms we never expected. Saturn, with its golden rings and family of moons, showed us the elegance and beauty of a giant world. But now, as we travel farther outward from the sun, we reach a planet that is far stranger and more mysterious. A world that does not shine with Jupiter's storms or Saturn's rings, but instead surprises us with its odd tilt, icy atmosphere, and unusual character. This is Uranus, the seventh planet from the sun, and perhaps the strangest giant of them all. Uranus is often called an ice giant, along with Neptune. Unlike Jupiter and Saturn, which are mostly hydrogen and helium, Uranus contains far more water, ammonia, and methane. Ices in astronomical terms, though here they exist as superheated fluids under pressure. Its diameter is about 50,700 kilometers, making it 4 times wider than Earth but much smaller than Jupiter or Saturn. Despite its size, Uranus is far less dense. It is a planet of light materials, layered in clouds and icy mixtures, without a solid surface beneath. What makes Uranus most peculiar is its tilt. Every planet spins like a top, with its axis pointed at some angle. Earth's axis is tilted 23.5 degrees, giving us our seasons. Saturn tilts 27 degrees. But Uranus is tilted a staggering 98 degrees. It rolls around the sun on its side. For nearly half of its 84-year orbit, one hemisphere faces continuous sunlight, while the other lies in darkness. Seasons on Uranus last over 20 years each, creating an alien cycle unlike any other planet. Scientists believe this tilt may have been caused by a massive collision with an Earth-sized body long ago, knocking the planet onto its side and leaving it spinning in this bizarre orientation. Its unusual tilt also affects its magnetosphere. Most planets have magnetic fields aligned roughly with their spin, but Uranus's magnetic field is tilted 59 degrees from its axis and offset from its center. This creates a magnetosphere that wobbles and twists as the planet rotates, producing auroras and fields far stranger than those of Earth or Jupiter. From a distance, Uranus looks calm and featureless, a pale cyan globe in the darkness. Its color comes from methane in the upper atmosphere, which absorbs red light and reflects blue and green. For decades, it seemed like a quiet, dull planet. But closer studies have revealed that beneath this calm face, Uranus hides violent winds that can reach 900 kilometers per hour. Storms have been detected too, though they are far subtler than the dramatic bands of Jupiter or the rings of Saturn. Uranus in many ways is a quiet giant, but not a simple one. The cold of Uranus is extreme, with an average temperature of about -224 degrees Celsius. It is the coldest planet in the solar system, colder even than distant Neptune. Why it is so cold remains a mystery. Most giant planets release more heat than they receive from the sun, but Uranus radiates almost none. Some scientists think its violent collision in the past may have caused it to lose its internal heat, leaving it strangely frigid compared to its neighbors. Uranus also has rings, though they are far fainter than Saturn's. Discovered in 1977, Uranus's rings are dark, narrow, and composed of small particles. There are 13 known rings, with gaps between them, making them difficult to see from Earth without special instruments. They lack the brilliance of Saturn's icy bands, but add to Uranus's mysterious character, a hidden adornment only visible when light passes through them at just the right angle. Around Uranus orbits a collection of at least 27 known moons, each named not after gods as with most planets, but after characters from the works of William Shakespeare and Alexander Pope. Titania, Oberon, Ariel, Umbriel, and Miranda are the largest and most studied. Titania and Oberon, the biggest, are icy worlds with ancient craters and deep valleys. Ariel shows signs of past geological activity. with smooth plains and ridges that suggest its surface once reshaped itself. Umbriel is darker, reflecting little light, a gloomy world far from the sun. But Miranda is perhaps the most bizarre of all, a patchwork moon with cliffs 20 kilometers high, the tallest in the solar system. Its surface looks as though it was shattered and reassembled, a chaotic landscape that hints at violent history. Despite all this, Uranus remains one of the least explored planets. Only one spacecraft has ever visited it, Voyager 2, which flew past in 1986. In that brief encounter, it revealed the tilted world, its faint rings, and its moons in detail for the first time. Since then, we have studied Uranus from afar, with telescopes on Earth and in orbit, but much remains unknown. What lies deep inside its icy layers? Why is it so cold? How do its seasons truly unfold over decades? These are questions waiting for future missions to answer. If you could visit Uranus, what would you see? From space, the planet would appear as a calm, pale turquoise orb, gently glowing against the blackness. Its rings would be faint arcs, barely visible except in the right light. Approaching closer, you would find a world with no solid ground, only endless skies of hydrogen, helium, and methane. Pressing down layer by layer into fluid depths, winds would rush around you, and storms might flicker in the distance, but the overall mood would feel eerily still. Looking outward, its moons would drift like frozen jewels, each with a story carved in ice and rock. Culturally, Uranus has been less celebrated than Jupiter or Saturn. Discovered only in 1781 by William Herschel, it was the first planet found with a telescope, expanding the known solar system beyond Saturn for the first time. Its discovery was revolutionary, proving that the solar system was larger than humans had imagined. At first, Herschel wanted to name it after King George III, but astronomers eventually agreed on Uranus, after the ancient Greek god of the sky. Uranus reminds us that the solar system is full of surprises. Just when we think we understand the pattern of planets, Uranus tilts over, spins sideways, and defies expectations. It is a planet of mystery, quiet on the outside, yet strange and complex in its details. It challenges scientists to think differently, to imagine planetary systems beyond the neat categories of rock and gas. For humanity, Uranus is also a stepping stone in exploration. A mission there could reveal how ice giants form, how their atmospheres behave, and even how planets in distant star systems, exoplanets, might work. Many exoplanets discovered so far are similar in size and composition to Uranus and Neptune, making these ice giants essential to understanding the broader universe. As we move past Uranus in our journey, we leave behind a world of calm skies, tilted horizons, and icy secrets. But ahead lies its twin, Neptune, a planet more dynamic, darker, and more distant still. Where Uranus seems subdued, Neptune reveals storms of incredible violence. Together they form a pair of outer giants, teaching us that even at the farthest reaches of the sun's influence, the solar system is alive with wonder and mystery. Uranus, with its tilted axis and pale turquoise calm, left us with mysteries of frozen atmospheres and strange seasons. But as we continue farther outward, we come to the very edge of the solar system's planetary family. Here lies Neptune, the eighth and most distant planet from the sun, a world of deep blue storms, fierce winds, and hidden secrets. If Uranus seems subdued, Neptune is its restless twin, darker, wilder, and far more dramatic. Neptune is about the same size as Uranus, with a diameter of roughly 49,200 kilometers, just slightly smaller. Like Uranus, it is an ice giant, made mostly of hydrogen, helium, water, ammonia, and methane. But while Uranus appears pale, Neptune shines in a rich, vivid blue. This striking color comes from methane in its atmosphere, but scientists suspect unknown factors deepen the shade, giving Neptune its jewel-like brilliance. From space, it glows like a sapphire in the darkness, mysterious and alluring. At nearly 4.5 billion kilometers from the sun, Neptune receives only about 1/900th of the sunlight Earth enjoys here. The sun is a bright star rather than a warming disk, yet Neptune is surprisingly active. Its winds are the fastest in the solar system, roaring at up to 2,100 kilometers per hour, nearly twice the speed of sound. Imagine storms larger than Earth itself, churning endlessly through alien skies. The most famous was the Great Dark Spot, discovered by Voyager 2 in 1989. This Earth-sized storm eventually vanished, but others have since appeared and disappeared, showing Neptune's atmosphere is constantly reshaping itself. The average temperature on Neptune is -214 degrees Celsius, but it radiates more heat than it receives from the sun. Unlike Uranus, which is strangely quiet, Neptune is alive with energy from within. This internal heat fuels its storms and explains why its atmosphere is so violent despite its great distance from the sun. Neptune's upper layers are made of hydrogen, helium, and methane, with thin high-altitude clouds of frozen methane crystals drifting above deeper layers. Beneath this lies a mantle of hot, dense fluids, water, ammonia, and methane under enormous pressure. Deeper still may be a rocky core roughly the size of Earth, though we may never see it directly. This hidden structure holds the key to Neptune's mysteries. Neptune also has a delicate system of rings. Unlike Saturn's dazzling bands, Neptune's rings are faint, narrow, and dark. Some are incomplete, forming arcs and clumps that seem to defy gravity. Astronomers believe small moons act as shepherds, keeping the arcs from spreading out. These fragile rings may be temporary, perhaps born of moon collisions long ago. But Neptune's true jewel is Triton, its largest moon. Triton is bigger than Pluto and orbits Neptune in the opposite direction of the planet's rotation, a retrograde orbit that suggests it was once a wandering object captured by Neptune's gravity. This capture was catastrophic, and over time Triton's orbit is decaying. One day, millions of years from now, it may be torn apart, creating new rings around Neptune. Triton is far from lifeless. Voyager 2 showed nitrogen geysers erupting from its surface, evidence of internal activity. Beneath its frozen crust may lie a hidden ocean, warmed by tidal forces from Neptune's pool. If so, Triton could be one of the outer solar system's most promising places to search for life. Even at the edge of sunlight, nature finds ways to keep worlds alive. Neptune's magnetic field adds to the mystery. Like Uranus, it is tilted and offset, producing a lopsided magnetosphere that twists as the planet rotates. It creates faint auroras, glowing in ultraviolet light. Even this far from the sun, Neptune reminds us that magnetic forces, invisible but powerful, shape space itself. Its discovery is a story of reason over chance. In the 1800s, astronomers noticed Uranus's orbit did not match predictions. Something unseen was tugging at it. Using mathematics, Urbain Le Verrier in France and John Couch Adams in England predicted the location of a hidden planet. When Johann Galle turned his telescope to the sky in 1846, Neptune was exactly where the equations said it would be. It was the first planet discovered by calculation, a triumph of human intellect. Since then, Neptune has remained largely unexplored. Only Voyager 2, during its 1989 flyby, has visited. It revealed Neptune's storms, its faint rings, and Triton's geysers. The images were astonishing, but fleeting. Voyager continued on, and no mission has returned. For more than 3 decades, Neptune has waited in silence. If you could stand near Neptune, the sight would be breathtaking. Its deep blue glow would dominate the sky, with clouds racing at unimaginable speeds and storms flashing with lightning. Its faint rings would arc across the darkness, and Triton would orbit in eerie defiance, a frozen moon with secrets beneath its crust. The sun would appear as no more than a distant star, yet Neptune itself would blaze with energy. Neptune is not just the last planet. It is the guardian of the outer frontier. Its gravity shapes the Kuiper belt, where countless icy worlds like Pluto drift. It captures, scatters, and shepherds these objects, marking the transition from planetary family to interstellar space. Beyond Neptune lies the unknown, dwarf planets, comets, and the edge of the sun's influence. The name Neptune fits perfectly. In Roman mythology, Neptune was the god of the sea, and here, at the solar system's edge, the planet resembles a vast cosmic ocean, deep, dark, and stormy. Just as Earth's seas once symbolized exploration, Neptune reminds us of the boundless mysteries still before us. For scientists, Neptune is not just a curiosity. Most exoplanets discovered so far are Neptune-sized worlds, orbiting distant stars. By studying Neptune, we understand not just our own solar system but the galaxy beyond. It may hold the key to unlocking the nature of the most common planets in the universe. But Neptune still asks questions we cannot yet answer. Why does it have the fastest winds in the solar system? What fuels its ever-changing storms? What lies beneath Triton's icy surface? Could life survive in a hidden ocean at the edge of the sun's light? These mysteries are reminders that exploration is far from over. Future missions may one day orbit Neptune, probe its atmosphere, and land on Triton's surface. They may reveal oceans hidden in ice, storms roaring from within, and chemistry we have never imagined. Neptune may be distant, but it is a destination waiting to reshape our understanding of worlds and life. And so, as we leave Neptune behind, we conclude our journey through the solar family. From Mercury's scorched plains to Venus's inferno, from Earth's living oceans to Mars's silent deserts, from Jupiter's storms to Saturn's rings, from Uranus's tilted calm to Neptune's restless winds, we have seen worlds of every kind. Each one is a chapter in the story of the solar system, a story of creation, diversity, and endless wonder. Yet beyond Neptune, the story does not end. The Kuiper belt stretches outward, the Oort cloud farther still, and then the stars. But within these 8 planets we already see the universe in miniature. Heat and cold, chaos and balance, lifelessness and the possibility of life. Neptune, the distant blue giant, stands as both an ending and a beginning, the final planet of our solar family, and the gateway to the infinite cosmos beyond. We began our journey with Mercury, the smallest planet, racing around the sun in just 88 days, its surface scorched by unbearable heat and frozen by endless nights. A world of extremes. Mercury taught us about survival at the very edge of possibility. Then we moved to Venus, Earth's so-called twin, but one cloaked in poison. Its dense atmosphere of carbon dioxide turned the planet into a furnace, a lesson in how fragile balance can be. Venus is both beautiful and terrifying, a warning of what happens when the greenhouse effect runs unchecked. From there we arrived at our home, Earth, the only planet we know where life thrives, where oceans shimmer, continents drift, and clouds dance in the sky. Here we saw the perfect balance of distance, air and water. A balance that makes life not only possible but diverse and rich. Earth reminded us why exploration matters. Because it is from here, our small blue planet, that we step out to understand the cosmos. Beyond Earth lay Mars, the red desert world, with canyons deeper than anything on Earth and volcanoes taller than Mount Everest. Mars whispers of a past that may have included rivers, lakes, and perhaps even life. Today, robotic explorers roam its dusty plains, and one day, humans may follow. Mars represents both history and future, a reminder of our curiosity and ambition. Next came Jupiter, the king of planets, a giant so massive it could hold more than 1,000 Earths inside. With its great red spot and powerful magnetic field, Jupiter showed us a world of storms and chaos, but also a protector. Its gravity shielding the inner planets from dangerous comets, and its moons, especially Europa, offered hope for hidden oceans and life beneath the ice. After Jupiter, we reached Saturn, the jewel of the solar system, crowned with magnificent rings. Its moons too were extraordinary. Titan, with lakes of methane, and Enceladus, with geysers spraying water into space. Saturn revealed beauty on a cosmic scale, teaching us that sometimes the universe surprises us with elegance as well as power. Then came Uranus, a planet tipped on its side, rolling through space with seasons that last decades. Its pale turquoise glow and tilted magnetic field made it unlike any other. With its strange moons and faint rings, Uranus reminded us that the solar system is not a neat, predictable place, but a place where the unexpected thrives. Finally, we reached Neptune, the restless blue giant at the edge. Here we saw winds faster than the speed of sound, storms that appear and vanish, and a moon, Triton, erupting with geysers of nitrogen. Neptune marked both the end of our planetary journey and the beginning of something greater, the gateway to the Kuiper Belt and the stars beyond. Each planet told its story. Together they created a grand tale of diversity, extremes, and wonder. Some are scorched, some frozen, some stormy, some calm. Some hold promise for life, others serve as warnings of destruction. But all remind us that the universe is vast, creative, and full of surprises. Think about what we have seen. Mercury's extremes, Venus's inferno, Earth's balance, Mars's potential, Jupiter's power, Saturn's beauty, Uranus's tilt, and Neptune's storms. 8 planets, each one unique, yet all part of one family, the solar family. And what does this family teach us? That Earth is precious, rare, and fragile. That our place in the cosmos is not isolated, but connected to worlds beyond. That by exploring other planets we understand not only them but ourselves, our past, our future, and our potential. The solar system is 4.5 billion years old, yet we are only just beginning to explore it. Spacecraft have flown past every planet, but only Earth and Mars have been studied in detail on the ground. Vast mysteries remain. Oceans beneath icy shells, atmospheres hiding unknown chemistry, storms we cannot yet explain, and questions of life that remain unanswered. The journey does not end here. Beyond Neptune lies Pluto, the Kuiper Belt, the Oort cloud, and then the stars. But before we dream of distant galaxies, we must understand our own backyard. The 8 planets are not just objects in the sky. They are laboratories of science, each one offering lessons about how planets form, evolve, and sometimes, how they die. As we close this journey, imagine looking back from far beyond Neptune. The sun glows faintly in the distance, and circling it are 8 tiny dots, each a world with its own story. One of them, a small blue dot, is our home. Everything we have ever known, every person who has ever lived, every moment of history, exists on that dot. Yet surrounding us are planets that show us what else is possible. Exploration is not just about discovery, it is about perspective. By studying the solar family, we see our place in the universe more clearly. We realize how fragile Earth is, how rare life may be, and how much there is still to learn. And perhaps, one day, humans will not only explore these worlds with machines, but will set foot on them, turning stories into experiences, and dreams into reality. So as we leave behind Mercury's heat, Venus's clouds, Earth's life, Mars's deserts, Jupiter's storms, Saturn's rings, Uranus's tilt, and Neptune's winds, we carry with us a single truth. The universe is vast, mysterious, and full of wonders waiting to be found. And this is only the beginning. The solar family is our family, its story is our story. And as long as we look to the skies with curiosity and courage, the journey will never truly end.